This is the Chem 1 lecture for nomenclature over covalent compounds. So this is the first of 3 different systems. We're going to learn today that there is a specific naming system when you name covalent compounds. There is a different naming system when you name ionic compounds. And lastly, there is a naming system when you name acids. Today we'll be focusing on covalent compounds. How to identify covalent compounds versus ionic versus acids. So for covalent, if you remember last unit, it was a bond between 2 non-metals. So you'll need to use your periodic table. Here's my lovely periodic table. There's that zigzag staircase, and non-metals are to the right of that staircase as well as hydrogen. And so if you have a formula like NH3, you have 2 nonmetals and you'll use the covalent system. For ionic, if you remember, that was a bond between a metal and a nonmetal. Or the nonmetal could be a group of nonmetals called polyatomics. So for example, NaCl is a metal and a nonmetal. Or you might see something like this. That's a metal, and this is a group of nonmetals. And then lastly, what's probably new for us are acids. These are compounds that are going to begin with hydrogen. So if they're starting with an H, you're going to use the acid nomenclature. So it's really important to keep these 3 systems separate. And so use these techniques to know which system are you working in, covalent, ionic, or acids. Okay, let's use a periodic table and practice. So Mg is to the right of this, or left of the staircase. That's a metal. This is a group of nonmetals. This is an ionic compound called magnesium sulfate. Okay, here it begins with an H. That's new today. That's an acid. And then you'll learn about ClO3 is chlorate. So this is chloric acid. Here is P and F. They both are to the right of that zigzag. So you have 2 nonmetals, P and F. And so that's a covalent compound. Here you have cesium and you have oxygen. Metal, nonmetal is ionic. This next one's a tough one. These are all nonmetals, but you're going to learn that NH4 has a charge and NO3 has another charge, and there's a full transfer, so that's actually an ionic compound. And then here we have, starts with an H, so it is acid. So like I said earlier, we're going to focus on the covalent nomenclature system today. And here's a cute little joke. I thought you said the chemical composition for water was H2O. The student misunderstood that H2O would have this formula, and so he wrote out the alphabet H through O. So with nonmetals, you're going to see some similar combinations, like here sulfur is bonded with oxygen, but it's the number of oxygens that differs, and so we can't make up like a new name for oxygen each time, so we use something called prefixes. So when there's 1, we say mono. When there's 2, we say di. And when there's 3, we say tri. So in a moment, you're going to learn this is sulfur trioxide, sulfur dioxide, sulfur monoxide. So rules for naming covalent compounds. Number 1, name the least electronegative element that's listed first. So what we just saw, sulfur is less electronegative than oxygen, so you would just name it sulfur. Step 2, use the prefixes to indicate the number of atoms. Omit mono for the first element. So this is typically where we're going to see a struggle. So mono is 1. So if you remember SO, this was sulfur monoxide. So we can use mono if there's 1 of the second atom, but we would not say sulfur monoxide. So mono is the only prefix we don't use for the first element. Now if this was 2, we would say disulfur dioxide. So sometimes y'all take mono and then you just never put a prefix on the first one. It's only for mono. We only use it on the second element, not the first. And then we'll change the second nonmetal to the ending of IDE. So that's why I said sulfur monoxide instead of sulfur monooxygen. So here are the prefixes. We've mentioned a few today. You do need to memorize the first 10. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, and I think in math class you all have septa, and so typically y'all have trouble with remembering the prefix for 6 and 7. So in chemistry, 6 is hexa, 7 is hepta, 8 is octa, if you think about octopus having 8 tentacles, 9 is nona, and 10 is deca. Okay, so now let's use our naming system. So name NO. So the first element, N, is nitrogen. Notice I do not change the ending of the first one. I have one of them. I am not going to put mono on the first element. But I notice that the second element, there's also one of them. So I will use the prefix mono and then oxygen, and we change that ending to IDE for the second element. So let's name H2O. You might be thinking that's water, and yes, we can use its common name, but for the sake of today, because we're learning the system, how could we name H2O using this covalent nomenclature system? So our element is hydrogen. There's 2 of them. The prefix for 2 is di, dihydrogen. There's 1 oxygen. We can use mono on the second element and change the second element to IDE, dihydrogen monoxide. So if you want to freak someone else out, you could say, I can't believe you're drinking dihydrogen monoxide. Let's see if we can name P3S5. So 3, the prefix for 3 is tri, P is phosphorus, that should be a US. What's the prefix for 5? Penta, S is sulfur, that we're going to change to sulfide. CCl4 is carbon tetrachloride. N7AS9. So 7 is hepta, nitrogen. 9 is nona, arsenic. Arsenic will go to arsenide. That usually freaks y'all out a little bit. AS is arsenic. And something that we kind of unofficially do is like if you have a double vowel, notice I'm just dropping one of them instead of nana with another A. We just kind of drop one of the same vowels. And then lastly, SF6, sulfur hexafluoride. There's a pretty funny, I think it's like Kelly Ripa and someone bring a scientist sulfur hexafluoride. If you consume it, it does the opposite effect of helium. It's like it makes your voice really, really deep. Okay, with every system, you're always going to name it and then also write the formula. So now we're going to go backwards. Now, because they've given us the name arsenic trichloride, we can write a formula. So covalent's pretty straightforward. Just write what you see. Arsenic is AS. Trichloride indicates there's 3 chlorines. You're done. When we get into other systems, there's crisscrossing and way more complicated stuff, but let covalent be simple. So dinitrogen indicates 2 nitrogens. Pentaoxide indicates 5 oxygens. Tetraphosphorus decaoxide. So tetra is 4, phosphorus is P, decaoxide, oxygen with a 10. Notice we're not simplifying anything. You write exactly what it is. Carbon monoxide is just C capital O. Make sure you don't make it look like cobalt. Diphosphorus pentoxide. You'll notice oxygen gets a lot of play for these covalent compounds. And dichlorine indicates 2. Heptaoxide, once again we're using oxygen. Hepta is 7. And never reduce a covalent compound. So as I mentioned earlier, if we give you the formula H2O, you can use the common name as water. We're actually going to say, please do that instead of dihydrogen monoxide. And there's one other one that we want you to know its common name, and this is more for future units when we're saying, hey, you need to mix this with water or you need to mix this with ammonia. We want you to know that ammonia is NH3. Yes, the official systematic name nitrogen trihydride, but if we give you water or ammonia, we are expecting you to know H2O and NH3. And then lastly, you see diatomics again. So each time we see them, they've kind of stepped up a little more in importance. And so diatomics are the 7 elements on the periodic table that when they're alone, not in a bond, you're going to see a subscript 2. And if you put them on the periodic table, so there's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, they create a 7. Some people, there's a saying, I bring clay for our new house. Or some put them all together to make one word, Hofbrinkel. So whatever you got to do, make sure you know these 7s. And so what it looks like with naming is that if we say write the formula for bromine, we're expecting you to write Br2, not just Br. And then vice versa, if we give you I2 and want to know the name of this, it's not iodide in a bond, it's just the element iodine, because these they're an element, but they exist with another one of them. There's 2 of them together. So let's see if we can find some mistakes in the following name. So this student tried to name NO as mononitrogen monoxide. Their mistake was using mono on the first element. So you can use mono on the second, just not the first. N2O5, they named it dinitrogen pentoxide. So you don't use mono on the first, but you can use all the other prefixes. And so because there are 2 atoms of nitrogen, we're going to say dinitrogen pentoxide. NH3, nitrogen trihydride. Yes, that is the technical name, but we are asking you to recognize the common name of NH3, which is ammonia, a household cleaner. And then I2, they're seeing it as a bond, and it is actually just a diatomic element. So we would just say the name of the element, which is iodine. I think this is the last slide, and now we're going to look for the mistakes in the formula. So this student was trying to write the formula for carbon dioxide. They gave carbon a 2. It should have just been CO2. Fluorine, they just said the symbol was F, but we know fluorine is a diatomic, so it should have been F2. Sulfur heptaoxide, so hepta means 7, so this should have been SO7. And then xenon tribromide, and they wrote XeF3, and so bromide is not fluorine, so it should have been XeBr3. Okay, thanks for listening.